Hi, I'm Dan Skyba. I'm the Director of Product Management for Supersonic Imagine, and we're here to talk about UltraFast Doppler. This takes our existing technology of having an ultra-fast imaging engine in the product, previously leveraged for shear wave elastography, and applies it into a new area, which is Doppler vascular imaging. In Doppler vascular imaging, as you know, color Doppler images generally demonstrate mean flow. But with our ultrafast engine, we now have the capability to create ultrafast Doppler images at sampling rates that you would normally expect in pulse wave Doppler, which allows us to retrospectively calculate spectrograms from color Doppler images in full fidelity as you would get in pulse wave Doppler. So that allows the clinician to now acquire about 2 seconds of data, remove the probe from the patient, retrospectively access the data, and put multiple sample volumes up on the imaging display and display multiple spectrograms simultaneously. So you can imagine the clinical benefit is that you can take a look at velocities pre-stenosis, peak stenosis, and post-stenosis all in the same image. Many people may know us as a product that was originally dedicated to small parts imaging, breast imaging, thyroid imaging, but as you can see by these advancements, we've really now become a more full-fledged radiology product. Our shear wave elastography is available on all of our transducers, and with our move into spaces like evaluation of liver fibrosis with shear wave elastography and into vascular imaging, we're really now ready to fulfill all of the needs of the clinician in ultrasound.
I will start by scanning her carotid and just optimize my image quality, adjusting my auto GGC and my overall gain and my mapping. So you can see the excellent image quality that this transducer provides. So I'll just go longitudinal, assess the carotid, scanning longitudinal and transverse. So once I've optimized my image, I can go ahead and go into conventional Doppler, color Doppler, and I can change my box size by selecting and using the trackball and touch ring to change the position and size. So this is our conventional Doppler. And just want to show you observe the excellent spatial and temporal color resolution. Also, the image quality is maintained when the color Doppler is turned on. So I'm going to freeze this conventional color image, and I just want to point out the frame rate, 16 Hertz. I'm going to go back to real time. So once I'm on my image that I want, I can do my UltraFast Doppler acquisition. That's by one touch of a button. So notice I've taken the transducer away from the patient. That was a 2 to 3 second acquisition, and now the Explorer is just processing the information. So all this raw data will remain accessible for future analysis and quantification. So the UltraFast Doppler acquired all the flow information in this box simultaneously here. See, we now have a frame rate of 77 Hertz. So because this is so high, we have total synchronization with the cardiac cycle. So I'm going to play our cine loop here, and you can see the excellent detail of the transient flow that occurs over the cardiac cycle. So we can display this several ways. I'm going to show you the quad screen format, and this will allow us to look at 4 different views. The first one is the clip, which we can play. Below it is the peak systolic frame, and we have the mean velocity and the max velocity, and this is over the cardiac cycle. So I'm going to select the peak systolic frame, go back to my main screen, and display the peak systolic frame. I'm going to zoom on my image. I can now add my spectrograms. So I can place my sample volume wherever I want. So notice the flow profile is changing as I move across the vessel. I'm retrospectively quantifying the flow information I acquired using the UltraFast Doppler. I could do an angle correct if necessary, change my sample size. I can shift the baseline, change my gain, and my scale. So I've selected the auto trace, the pulse wave auto trace, which will automatically calculate my peak and end diastole measurements, also give us a resistive index and a pulsatility index. So I can add another second spectrogram. Again, deciding where I want to place this, adjusting my baseline, the gain, sensitivity of the auto trace. If I don't want to use the auto trace, I can manually measure this. Can go into measurement. If I want to do a straight velocity, can also add a velocity measurement here. I'm going to add a third spectrogram. Again, deciding where I want to place it. There's our venous flow. That's arterial. Changing the baseline, scale if necessary, and our gain. So here we have 3 spectrograms with your measurements listed over on the right. We'll place auto trace. And here's our measurements. So I'm going to play the cine loop after these 3 spectrograms. So as I play the loop, you can appreciate the exact synchronization of the arterial flow with the color flow information throughout the cardiac cycle. So this original acquisition, as well as the measurements, can all be stored. If additional calculations are needed, the spectrograms can be deleted and new measurements can be added. An exam can be reopened at a later time to do the retrospective measurements. So in summary, the UltraFast Doppler uses high frame rates to view details such as fine spatial turbulent flow and high temporal resolution flow without compromises. In addition, UltraFast Doppler provides a complete spectral Doppler analysis in seconds with multiple sample volumes in the same cardiac cycle. Supersonic shear wave elastography and ultrafast Doppler can only be found on the Explorer system, and as the Explorer is the only ultrasound system with an ultrafast imaging architecture.